Hello, guys. Good evening. I hope you all are doing good today. So, today we are covering up a video in our data engineering series. So, thank you all for the massive response we have got till this point. So, we are continuing on this today. And before we jump to the video, who are we? We are Data Valley, the fastest growing edtech company of 2025. Okay. Okay. We are the fastest growing edtech company of 2025. Okay. Sorry about that. So we are the fastest growing edtech company of 2025. So you can check out on our website DataValley.ai. So you'll get a good idea about what we can do for you. We provide you we provide you help in regards to IT solutions, trainings, and placement support as well. So if you are in any part of your career development, please feel free to check out on our website and reach out to our colleague. They'll be able to help you with whatever part you need your help in. Okay, so good luck with you all in that, and you all know the routine. Grab your pens, grab your notebook, have a coffee, and come sit and make sure that you spend a good well enough time to learn all the concepts that we are learning today. So myself, Franklin, I have 3+ years of experience as a data engineer, and I'm very glad to bring this to you all because this is like I feel immense pleasure in sharing the knowledge that I've gained in the industry, and I want to contribute to the development of the data engineering community. So I'm glad to bring this to all of you. So good luck in learning all the resources today. So today we are covering up on our 10th part of this series. So today, ultimately, we are going to cover a few topics in relation to Spark. So we all know about Spark, isn't it? Spark is an open source. It's a distributed processing engine. Okay. So there are different strategies and different things that we do along in using a Spark. Let's say you know to develop a Spark job. Let's say you know to write some Spark code. Yes, that is well enough. Everyone knows that. Or if you're learning, you might be learning and you might be able to write at least few lines of code. But do you know how to submit a Spark job? Do you know where to submit a Spark job? Do you know what are the key parameters that you need to consider while submitting a Spark job? Or do you know how to handle errors in your PySpark application? These are the 4 things that we are going to cover up in today's session. So to start with, how do you submit a Spark job? Okay, to submit a Spark job, the ultimate and the most important technique is called as the Spark submit method. Okay, and if you ask me what is a Spark submit is a command line utility that is used to launch your Spark applications on a cluster. And to submit your Spark application or your job, the most primary or most widely used industry practice is to use a Spark Submit command utility. And while using the Spark Submit, you also use various parameters to control how your applications would run on the cluster. So Spark Submit is a command line utility which you use to launch your Spark application. And along with the command line utility, you specify varieties of parameters to make sure that how you control your application on your cluster level is defined. And the main thing about the Spark Summit is it provides an unified interface for interacting with your Spark cluster. Okay, it provides you with the unified interface for interacting with your different cluster managers as well. So what do I mean by different cluster managers? We have different cluster managers like standalone, Yarn, Mesos, and Kubernetes as well. So for varieties of these kind of cluster managers, Spark Summit provides you with the unified interface, and you also have different kinds of deployment mode. So what do I mean by deployment mode? So deployment mode comes in two varieties. The one is the client fashion and the other one is the cluster fashion. So in the client machine, you submit your Spark application to your client, and talking about the cluster mode, you submit your code to the cluster. So these are the varieties of methods you have to manage your clusters and different modes to manage your deployment. So therefore, Spark Summit simplifies all these process of submitting your jobs without requiring specific configuration for different environment. So let's say you have different environment. So standalone is an environment, Yarn is a different environment, Mesos is a different method, Kubernetes is a different deployment mode, and you have client and cluster mode as well. So for these kind of different configuration and different setups, you can use Spark Summit as a unified platform where you can submit all this Spark jobs. And then we have other methods as well. Then we have a programmatic submission method. So what is the programmatic submission method? So you can submit your Spark jobs programmatically from within other applications. So from application, you can submit a job, you can submit a Spark job application as well. So how do you do it? You use a special library called as Spark Launcher in Java. So while if you're developing the application in a Java based environment or a Java application, you can use a library called Spark Launcher, and then from that you can launch your Spark job programmatically. This is often used when integrating Spark jobs into larger systems or workflows controlled by a different application. So you use this method when you're trying to integrate your Spark jobs with larger systems or workflows controlled by different applications. So what do I mean by that? You have different application. Different applications are going to handle different systems and your workflows. So to integrate your Spark along with that application, you use Spark Launcher along with your Java to perform a programmatic submission. And then we have REST APIs. So how do you submit a Spark job using a REST API? So these REST APIs are provided by your Spark itself. So Spark provides your REST API, and by using the REST API, you submit and manage your job programmatically. And this can be useful for automated job submission and interaction with your Spark clusters as well. And REST API being programmatical kind of submission, it is on top of a programmatical submission. You also get advantage with the other operations like automated job submissions and interaction with your Spark clusters. Then you have Levi. So Levi is an open source REST interface for your Spark application. So by using this open source REST interface, your Spark, you can submit your job as well. And not only just the submission, you can also interact with these Spark jobs from anywhere. So what do I mean by anywhere? So anywhere includes different shells like Python or Scala. Now how do you get a Python shell or a Scala shell? You go into your command prompt and you invoke your Python or your Scala shell, right? By using those, you can interact with your Spark job using Levi, which is an open source REST interface platform. And it is based on IPython or Jupyter and designed for multi-user environments within Hadoop ecosystem. Levi can also handle Yarn impersonation for security. So it is based on IPython and Jupyter. And also the benefit of using Levi is that you can, it's supported for your multi-user environments along with Hadoop ecosystem. So you can opt for Levi if this is your business use case. Then you have Databricks jobs. So before jumping to Databricks jobs, let's talk about Databricks. What is a Databricks and what is a Spark? So Spark is an open source distributed data processing engine. And Databricks is a proprietary database. Okay, it is not an open source software or an application, but Databricks is a proprietary application that belongs to Databricks. And Databricks is an upgraded and an updated version of your Spark. So the same developers that developed the Spark developed your Databricks application as well. So Databricks is proprietary, and it comes with a lot of integrations and additional functionalities in comparison to your Spark. So talking about Databricks jobs, how do you submit your Spark job? So if you are a user of a Databricks platform, what you can do is you can configure your Spark jobs within the Databricks jobs UI. So within the jobs UI of your Databricks, you can submit your oh sorry yeah you can submit your Spark job as well using the Databricks UI, and it leverages the Spark Submit compatible options behind the scenes. So behind the scenes, what's happening? So whatever the Spark Submit compatible options are available, it avails it and then submits your Databricks. It submits your Spark job in your Databricks. You can also use Databricks API or CLI to create and manage these jobs. So you have an option called Databricks API with which you can create and manage your Spark jobs as well. Then we have got an interesting person called Apache Airflow. So you might all be wondering that Apache Airflow is a work orchestration tool, or it's a workflow management tool. So how is it going to support with my Spark Summit? Airflow is a popular workflow management platform. Yes, we all know that. But on top of that, it also can provide you with a setup to schedule and submit your Spark jobs. And if you are a user of Airflow, you all know that Airflow uses something called as an operator, right? So by using these operators, you can internally invoke a Spark Summit or a similar mechanism to run your Spark job. So these are the different methods that you have to submit your Spark job. And then where to submit your Spark job? Okay, you know how to submit your Spark job, but do you know where to submit your Spark job? Let's see it in detail now. The location from which you submit your Spark job is crucial and depends heavily on your chosen cluster manager and deployment mode. So, to submit a Spark job, there are two important things that you need to pay attention towards. One is what kind of cluster are you managing, and then what is the deployment mode that you're looking for. So, depending on this, you can choose your Spark application submit location. Okay, so depending on this, you can define your location. And what is the goal here? The goal is to ensure that the submitting application can communicate with the Spark cluster manager and has access to the application code and dependencies. So wherever you are submitting your application, okay, that is your submitting mission, you must make sure that your submitting mission can communicate with the Spark cluster manager, and also it has access to the application code and dependencies, because the machine that you submit, if it cannot communicate with the Spark cluster manager, you are not going to have a cluster invoked for your job application, right? So make sure that it can communicate with the Spark cluster manager, and also on top it can access the application code and then the dependencies as well, because to run your Spark application in a smooth fashion, you need dependencies. So for different kinds of setup, you need different dependencies, and these dependencies, you have to make sure that your machine is able to connect and communicate with. And now here is a breakdown for different scenarios. Okay, our very first submission method is a local machine mode. So where do you submit? As the name suggests, you submit it local. Okay, what do I mean by local? So local can refer to your PC, it can refer to your laptop. So these are different things that you have to submit your Spark job locally. So when to use it? You can use a local machine mode when your your primary local development is your, or testing or your debugging or your processing environment is your local environment. So you can opt for a local development only when you're going to use your local machine. Okay, so for example, let's say you're developing a code for a production and now you want to test it. Yes, go for your local machine. Let's say you have some application already running in your cluster or your production, in production, and now you want to test and debug certain errors, because these are the errors that you're gaining in your production. But you can't test and debug in your production environment, because that might end up in a lot of error, because that might lead up to worse and worse scenarios. So make sure that you have to use your local environment only for your testing, development, debugging, or worst case you can we all do this. We learn our Spark application in our local environment, right? That is our laptop and PC. So if you want to process these smaller data sets and you want to learn, go for your local machine. And how it works, you can submit the Spark job on your local machine, specifying local or local square bracket asterisk. So what do? You submit your Spark job to your local machine, that is your laptop or your PC, and in the node that you specify, the master you specify, are you running it in a cluster or in your local? So to run it in the local mode, you have to specify either local or local square bracket asterisk and as the master parameter. So for your master parameter, you specify if you're running your job locally. And this tells Spark to run your application using threads on your local machine. So when you specify, the master to be local, your Spark will, invoke threads which will initiate, to run your applications on your local machine. And by creating this threading option, you emulate, okay, it's not actual, but you emulate a distributed environment without actually needing a cluster. So you don't have a cluster, or you actually don't have a cluster environment in your local machine, but by invoking kind of threading, you are invoking a kind of a distributed environment, but not it is. You're just trying to foreshadow it, but not the actual distributed environment. And what are the key considerations that you need to have while choosing local machine? You have to consider that your performance is very limited depending on your local machine's resources. Let's say you have a 8 GB cluster node and I have a 16 GB processor in my laptop. So depending on my processor, my performance is going to be limited. All right. Then you have cluster environments. So in cluster environment, you have got three options. You have got gateway or edge node, you have got a master node, and then you have got a cloud platform. Talking about the cluster environment, the very first one we have is edge node. So you can use edge node for your production grade work. Okay. And talking about the gateway node, this is the most common and the recommended approach for production deployments. So if you have something to deploy and the production grade deployment, you always have to choose for your gateway node, and it is managed by your clusters like Yarn, Mesos, or Spark standalone. So if you see in local, you're developing the application locally in your laptop or your PC, right? But what's happening here? You are trying to use a cluster, and then from the cluster you invoke all your cluster or your Spark deployment. And if you talk in production, this is the most common and the recommended approach for your production deployments. So let's see how it works. A gateway or edge node is a machine within the cluster's network. So what do I mean by an edge node or a gateway node? So you're going to have a cluster of machines, right? and one of the machine from your cluster is going to be acting as your edge node. But though you submit your job, you know, though you submit your application in an edge node, you have to know that you're not running your main cluster or your Hadoop daemons in the submission that you submitted. Sorry, in the machine that you submitted. But rather, that machine is used to log in and just to run your Spark submit. And then in that edge node of your machine, you specify the cluster manager and the appropriate deployment mode. So you have a edge node from your cluster, you log in, you submit your Spark job or application, and you specify what is the cluster management, what is the cluster manager, and the appropriate deployment mode. The gateway node acts as the client, coordinating this job submission and interaction with the cluster manager. And then you have your key considerations. So, what are the key considerations I have in this? The gateway node needs the necessary Hadoop binaries, libraries, configs installed to interact with your cluster. So, your gateway node is going to act as your client machine, right? And this client machine is going to invoke the Spark application in your cluster application, cluster of or cluster network of mode. So, what you're going to do, you are going to have necessary Hadoop binaries, libraries, and configs installed in your cluster. And why is that? Because it is the gateway node is the one that is going to invoke all these interaction with the cluster. Therefore, you need all this pre-installed configurations set up. So for example, let's say your cluster mode is your yarn. Okay, in that case you need to have your Hadoop conf directory or your yarn conf directory environment variables set on your gateway node to help with the Spark locating your yarn resource manager. So if you have already the directory environment variables set it up, then your gateway node can easily you know help Spark to locate your yarn or your in other words yet another resource negotiator, which is going to negotiate between the resources. So you need to make sure that you have all these environment variables set before. And also you got to ensure that the gateway node has network access to the Spark master or yarn resource manager. So whatever the gateway node that you have from your cluster, this must have a network access to interact with your Spark master and your yarn cluster. Then we have got master node, which is also a standalone cluster. When would you use a master node or a standalone cluster? You have to use a master node when you are in need of a standalone Spark cluster. So as the name suggests, standalone. It's a single Spark cluster. Okay. And what you're going to do is you're going to submit the jobs directly from the master node. And this is when you have to use your standalone cluster. Let's see how it works. So you log into the master node directly. You execute your Spark submit command, providing the master's URL. So you provide the host ID. Okay. So you provide the master's URL, and then your Spark application gets running and it works. The master node will then handle the allocation of resources to your application. So what are you doing? You're logging into your master node, then you execute the Spark submit command, then you provide the master's URL, and therefore your master node will then handle the allocation of resources to your application. So whatever the resources are required by your application, your master node is the one that provides it. So you're not using yarn. So in the gateway node you use yarn, right? So yarn mesos, and then from that you negotiate resources, right, in a cluster. But in here your Spark itself is going to handle all the allocation of resources for your application. And then what is the key consideration? This is less common in cloud environments or production settings, where a dedicated gateway node is often preferred for better security and isolation. If you are, you know, going for a production grade, then make sure that you use only gateway node, not master node, because you're compromising on your security and you're going to have, you're not going to have isolation as well. So if you prefer security, and as a data engineer, yes, you need to prefer it, because using standalone or a master node is an less common practice. So do not go for it. You have your industry best, go for your gateway node or your edge node. Then you have cloud platforms. So you can use cloud platforms to run your Spark application. So talking about cloud platforms, you have Databricks and Azure Machine Learning. So when should you use a cloud platform? You have to use cloud platform when you have to run your uh, Spark application in a cloud environment. And why is that? Because cloud platforms often provide their own interfaces or APIs for submitting Spark jobs. So you need to submit your Spark job, and cloud platforms provide their own interfaces and APIs, therefore helping you to submit your Spark jobs at ease. And how is it helping, as a developer? What's happening is Spark job, sorry, the cloud platforms take away the complexities I have with Spark Summit. So therefore, you can avail for cloud platform, which is, a very good practice or a well-known practice. So you can use cloud platforms to submit your Spark job. And let's see how it works. So instead of directly using Spark Summit on a specific machine, you might use a web UI, CLI, or SDK provided by the cloud vendor. So what you're doing, you're using the web UI or CLI or a SDK, so command line interface or a software development kit provided by your cloud vendor. So whoever your cloud vendor could be, you're going to be provided with a web UI or a CLI or a SDK. And from these, instead of submitting your Spark job directly using Spark Summit on a specific machine, you're going to use these kind of web UI, CLI, and SDK, and then you're going to interact with your cloud to support your Spark application. So these tools internally handle the interaction with the cluster management service to launch your Spark application. And then let's talk about the key considerations. These platforms offer features like managed clusters, auto scaling, integrated logging, and monitoring, which streamline the deployment and management of Spark jobs. So, talking about cloud, you have multiple benefits and advantage because of the features it provides, right? And the cloud deployment method provides you with the managed clusters. So what do I mean by managed clusters? So you all know clusters, right? It's going to be a group of machines. So talking about managed, it is going to be managed by your cloud provider. So I already told you, right? It's going to take away the complexities of your Spark submits by managing your clusters. So your cloud provider will manage all your clusters. It provides us with auto scaling. So auto scaling is when you need to scale in or scale out your application. So scale out is when you need to, increase the number of executors or your number of cores or number of, or your memory of your executors. Your cloud can handle it automatically, therefore providing you with the auto scale efficiency. And then it has integrated logging and monitoring. So by providing us with the integrated logging and monitoring, our cloud platform, provides us with a better uh, support for our submission of Spark job. And then you have logging and monitoring. So, by default your cloud is going to have all these kind of setups. And by using the cloud's advantage, you can actively monitor and look out for the errors, and you can actually have an audit of your logs, right? So you can go for cloud platform when you prefer these kind of features as well. And the cloud platforms are going to streamline the deployment and management of your Spark jobs. And then, yes, we already know that Spark Submit is the ultimate or the primarily used method to submit your Spark job. So, what are the key parameters that it takes? Okay, talking about the key parameters, we have multiple options. But before jumping to that, let's talk about the syntax. Okay, this is a double, uh, you can call it a subtraction symbol, or you can call it a minus, or you can call it an dash. Okay, so you're going to have double dash, and for all the parameters that you're going to specify, you're going to have a double dash. All right, and then without a space, you mention your class or the other parameter name, and then whatever is specified within a the brackets, that is your kind of your name. Okay, that is not your default or your mandatory name. That is just a naming convention. Okay, so this is going to be a parameter, and this is going to be the name that you would like to have for your application. All right, now the first parameter that we are going to cover is a class parameter. So dash dash class, and then you specify your main class. So this is the class parameter is going to, you're going to specify the qualified name of your main application class. So we have got our application, right? So for this application, we have got a main class. So you are going to specify that main class with the class parameter. And this is required only for your Scala and Java application, and not for your PySpark based application. So this is used to specify your main class of your application. Then we have got a master parameter. So the master parameter is used to define your cluster manager and the address of it. So your cluster manager can be Yarn, can be Mesos, it can be a Kubernetes, it can be different, right? And this is where you specify the URL of your Spark application cluster manager host. So examples include local square bracket asterisk, which means that I'm deploying my application locally. I've got a Spark hostname port, which is Spark standalone. Then I've got Yarn, which is going to be a Yarn based application deployment, and then you have got Kubernetes host address as well. So that is what you specify in your master parameter. And for Yarn mode, the cluster location is determined based on the Hadoop conf directory or Yarn conf directory environment variables. So if you are using Yarn mode, okay, so you're going to specify Yarn, right? So master Yarn, and when you're using Yarn mode, your cluster location is determined based on the Hadoop conf directory or your Yarn conf directory. So make sure that that is already set as your environment variable. And then you have got deployment mode. So for deploy mode, it takes a naming convention as well. So in the deployment mode, you can either mention it to be a client or a cluster. So the driver that you have, okay. So as we have seen earlier, for example, in your edge node, you have a cluster, and one of the machine in a cluster is going to handle your driver, right? So that is a client based. So you submit, that is going to act as your client, and then it is going to interact with all of your executors or your other machines. So therefore, you have to mention what kind of mode are you preferring. Are you preferring client mode, or are you preferring a cluster mode? Then you have a name parameter, which is going to take your application name. So whatever the application name that you would like to have, you specify it with your name parameter. And this is going to appear in all of your Spark UIs and in your logs as well. So make sure that you have different names for your different applications. The reason being, when you are looking for your logs, okay, when you're trying to look for your Spark UI. Okay, if you have a correct naming convention, it'll be easier for you to look into it. All right, so make sure that you have a proper naming convention. Therefore, it is easier for you to look, or have a look on your logs and look for any kind of errors, or for any debugging purpose. So make sure that different applications have a different naming convention. Then we have got a jars parameter. So the jars parameter will take a list of jars as well. So I mentioned comma separated list of jars. So you can mention one or more jars as well. So what happens with this parameter is that you add external jars containing your application code. So your jar application is going to have your application code, right? So you're going to specify that jar application name and also the dependencies to the class path. So whatever the jars, whatever the uh, jars that you have, which is going to have your application code, or to specify your class path for your dependencies, you can use this jars parameter. Then you have got py files. So py files is similar as well. It is going to take a comma separated list of Python files. So it can take one or more argument as your Python files. And then it is going to include Python files or archives, okay, .py, .zip, or .egg for PySpark applications, making them available to executors. So whatever you pass in your, dash dash py dash files and the list of Python files, your application is going to make sure that these are available to your executors. Then we have got dash dash files, and the files parameter also can take one or more arguments with a comma separated for each of your files. So what it does is it distributes additional files to executors. Oh, sorry about it. Okay. So it distributes additional files to executor working directories, such as configuration files. So py files will distribute your Python files or your archives to your executor. Similarly, the files dash dash files parameter will make sure that the additional files are sent to your executor working directories. So files can include anything like an configuration files, etc. Then we have got dash dash conf key value. So what this sets is it sets an arbitrary Spark configuration properties. So you can also load configurations from a properties file using the properties file. So you want to set different configurations for your Spark application. Then you mention it using a key and then a value. Okay, you mention like what is your executor, then you mention your size. Then you can use key as your argument, and then value as what the value is given to those argument as a for the key. So you set your configurations using dash dash conf. Let's say you don't want to use based on key and a value. Then what you can do is you can use dash dash properties file, which is going to have the path for your file. So by setting this, you can load the properties from your file directly instead of specifying it using key value in your configuration parameter. Then we have got a driver memory and an executor memory. So driver memory and you specify your memory, executor memory and you specify your memory. So this controls the memory allocation for your driver and your executor. For example, 1 GB for your 1 gigabyte. So sorry, 1G for your 1 gigabyte. So let's say you need to have your driver memory to be 1 GB. Then you specify it as 1G. Okay, so as you see here in small letters. And let's say you want 5G for your or 5 GB for your executor memory. Then you specify it as 5G. So this is your one of your important parameters within the Spark Summit. And then you can specify your Spark executor cores, and also you can specify the number of executors. So executor cores. So it is going to say that, how many what is the number of executors that you prefer, sorry, number of cores that you prefer. And for each core you are going to have an executor, right? So to put in other words, let's say I need 5 cores and 5 executor. So what it means is that I'm going to have 5 executor, and each executor core is going to have 5 nodes within. Okay, so as a whole I'm going to have 25. So 5 cores, and each core is going to have 5 executors. So that is what is meant by executor cores and num executors. So this defines the number of cores per executor and the total number of executors. A job processing 100 GB of data could use 10 executors with 4 cores and 10 GB of RAM each. Then you have got application jar or your Python file. So you are going to specify the path to your application's jar file or Python file. So whatever the, you have your jar file, right? So if you have your jar file or your Python file, you can use the application jar or Python file. Okay, you just put it. Okay, you don't have to use anything. So this is straight away, just put it straight away, and this is just a, straight away the path. So that's why I didn't mention anything at the front. So if there is a square, if there is a bracket, that's a naming convention. So you don't have to specify anything. You just put your jar file location or your Python file. I mean, not location, or your Python file. And then it can take optional arguments called as application argument. So when you specify, additional arguments, these are passed to the main method of your application. So here I've got a simple PySpark submit code to run a Spark standalone cluster. Okay. So as you see here, I've got a Spark submit, and then I'm mentioning my master. So master parameter is going to specify what kind of cluster manager. So I'm specifying it to be a standalone. So I'm specifying Spark along with the IP and its IP and the port number. And then I've got the deploy mode. So my deploy mode is going to be client. So you have client and cluster. What is the executor memory? I want 2G. So I'm going to have 2 GB for each of my executor. And then what is the number of executors I want? I want four executors. And then here is my uh, dash dash py files. So you can pass archives or any kind of Python files. So I have passed in my zip file here. So this is going to have all my dependencies. So I'm passing it my files. Then I've got my spark app.py, and this is my path to my uh, Python file. And then I've got arguments 1 and 2. So these are the additional arguments or optional arguments that are passed to the main method of my application. So this is quite a good example. I've got a notes here. So when I put this online, you'll be able to read through them. Sorry. And next, the final question for the day: how do you handle error in PySpark application? So yes, you can submit your Spark application now. You know where to submit it, how to submit it. You have all the parameters that you need to consider for your Spark application. But do you know how to handle errors in your PySpark application? So to handle errors in your PySpark application, the very first method that we have is try except block. All right. So what is a try except block? So try except block is like an Python paradigm, right? So if you have run the Python, uh, which we have already covered in our Python series, you would have had a good idea about how we implement try and except blocks. So talking about try except blocks, so try is the block that you want, that is your actual code that you need to try. An except block is the one that is going to have your errors. Okay, any errors that is raised from your try block will be passed on to your except block. Okay, and those errors are exempted from breaking your code or raising as a error. So whatever the errors that is coming in your try block, if you raise it and then pass it to your except block, it is not going to stop your job, rather it is just going to create an exception. And then finally is, so though you might try or though you might do an exempt, so even in that case, whatever the job has run or hasn't run, it has been broken or the job hasn't been complete properly, it doesn't matter. What happens with your finally is irrelevant of your output from the try and except block. I want you to do this. So this is the declarative kind of statement that we are passing to your Python, PySpark application, saying that no matter what has happened, I want you to stop the Spark application. So especially we use finally to clear out the resources or release any kind of resources that has been held, or like to close the database connection, etc. So Python's try except blocks to catch and handle exceptions that occur within your Spark application. This is the very first strategy to handle errors in your PySpark application. Then we have got login. So talking about login, you can use Python's built-in login module to track errors and understand the flow of your application. So if you need to track your errors, okay, then you can use the logging library or logging module provided by your Python, and it also helps you to track the errors and understand the flow of your application. So how to use it? What you can do is you can import, okay, the logging module, and then now you specify, okay, logging dot basic config level is equal to logging dot error, logger is equal to login dot get logger, and the name method. And now within the try except block, you specify the same. So you put all your code in here, and then you put an exception block. But instead of just raising an error and printing it, what you're doing is you're logging it. Okay, so why you're logging it? Because it helps you to track the errors, and it also on top helps you to understand how your application is flowing up. Okay, sorry, I left out explaining the try except block. So what I'm doing, first I'm creating a Spark session. This is just a boilerplate template, okay? So you can develop further from this. But this is a very basic one for you to understand better. So first I'm creating a Spark session. So Spark is equal to Spark session dot builder dot app name dot get or create. So I'm creating an application name called error handling. And now I'll be having here my PySpark code. So my PySpark code will have multiple actions, transformation. So transformations would include something like adding a column, removing a column, changing the uppercase, lowercase of the data, then changing the format of my data, handling null values. So different kind of transformations come into this PySpark code. And then if I'm finding it an error, I am putting that to the exception block. So except exception ASCII. So I'm getting all the errors from my try block to the except block. So once all this error has been raised or my application has run, no matter what, I want you to finally stop my Spark session. So I'm initiating a Spark. So Spark session is an entry point to your application. Okay. So you want to end the Spark job now. So you are releasing the resources at the end of your job. And next, to handle errors, you have something called as accumulators. So what these accumulators do is they help you to keep track of errors or invalid records encountered during transformations without halting the entire job. So let's say you have some invalid records coming from your coming that or that is how do I say it? Okay, you are trying to perform a transformation, and now your transformation has encountered an invalid record, and instead of breaking the entire job or stopping the application, what you can do is you can have an accumulator, And what these accumulators do is they track the errors, and then also they will be able to keep track of your invalid records as well. So whatever invalid records you had, it keeps a track of it. So it accumulates all those kind of information basically. So in here, I'm creating a Spark context. So Spark context is same as well. It is different to Spark session, but we will talk about it in detail in the next session maybe. But it is also an entry point to your application. So I'm creating a Spark job. So and now I'm passing in a variable called as error accumulator, and then I'm passing my Spark job, and then I'm using dot accumulator as well. And now within my function, okay, I'm validating the row. I'm using try except block. So I've got the validation logic here, I've got my exception block here. And then whatever the errors that has been raised, okay, whatever the errors that is coming through, I want to keep track of it. So I'm adding it to my accumulator. So error accumulator, it is going to have all my errors that are being raised during my exception error. So all that we saw is was in try except block, and within a try except block you can have your logging and your accumulator. And now we are going to talk in the context of your data frame API. So data frame API is used to create a data frame, right? So while creating a data frame, you have three options to handle your problematic records, and this is especially useful when you're trying to read data. So what are the options left for your PySpark data frame API? So while reading the data, okay, if I'm reading the data, how am I going to handle the problematic record? That should be your main question now. Okay. And you have three modes. So instead of going from the top, I'll explain from the bottom. So it's very easy. The first mode is called as fail fast. So what happens with the fail fast is, as soon as your while you're trying to read your data, if there is an error, it'll immediately seize the pipeline. Okay. So if you're trying to read a data that has some invalid records, it'll throw out a error, and it'll stop the pipeline. Okay. In other words, it'll cause a failure of your pipeline. Okay. Fail fast stops your pipeline immediately if there are errors. And what happens with the drop malformed? So it's again a data frame reader API option. What happens in this one is, if you are having some kind of problematic records, what it does is it ignores it and just loads whatever is right. So whatever the data is right, so whatever the data is correct, only that is loaded up in your data frame, and whatever is your problematic record, it gets pushed out. And then you have got permissive mode. So what is a permissive mode? So in the permissive mode, what happens is, you're going to allow all your problematic records to be stored in your data frame API. So in fail fast, if there is invalid record, the pipeline breaks. If it is a in drop malformed, you're going to take in only the proper records and leave out the malformed versions. And in permissive mode, you are allowing the invalid records, and what it does is it will create a new column named corrupt record to store the problematic records. So the permissive mode will allow, but it is just going to store it as a corrupt record, or sometimes it just stores as a null value. And then also you have an option within the data frame API. You can use something called as bad records path. Okay, you can set this option called as bad records path. So what happens is, if you specify this configuration, you have to specify a path to automatically redirect problematic records to a separate folder. Let's say I want to know, I want to understand, or I want to get an insight about the problematic records. Now what I can do is, whatever the problematic records that I am having, I can just pass it to a separate folder by specifying the bad records path. Simple. And here now I've got the common kind of Spark failures and how you need to handle it. So first, you might encounter a transformation time errors. So what is a transformation time errors? So let's say you have developed your Spark logic, and now you are having tough time trying to parse the logic. So if you have a bad parsing logic, or if you have some null data access, let's say you have some wrong schema, then you are going to have end up with the transformation time errors. So how do you handle it? You can add try except blocks in map for each functions. So you can use these kind of strategies to handle your transformation time errors. So basically it's a transformation error, right? Because you cannot pass through your logic. You didn't handle your null properly. So you are having a wrong schema. So these are the transformation errors. Then you have action time errors. So this is transformation type errors and this is an action type error. So action type error occurs when you call for an action. For example, collect is an action, right? Collect function is an action. So what happens is when you invoke a collect method, sometimes your driver memory overflows because action is going to call out all your transformation and it is going to load all your data, right? And it might result up in a driver memory overflow issue. And to handle this, what you can do is you can use persist or checkpointing, and also you can try to avoid loading all the large data set to your driver. And then you have got a cluster or a node level failure. So sometimes your executor might crash or your hardware might fail. But to handle this, what you have to do is you have to have Spark retries enabled. So make sure that you have got your Spark retries enabled so that even when there is an executor crash or a hardware failure, your new cluster gets initiated or a new executor gets executed. I mean, executed in the sense it gets launched successfully. You can also have checkpoint strategies for your data as well. So whatever the data has been processed, it stores up in an uh, you set a checkpoint so that instead of performing all your jobs from the start, because you have set a checkpointing strategy, only those data that need to be processed further will be processed. Then data quality errors. So talking about data quality errors, we have bad records and corrupt files. We just saw about the bad records and corrupt files, right? So we had different methods of handling the bad records. So for example, you can have bad records path, which is going to store all your bad records in a completely different folder. Or what you can do while loading, you can set functions like you know permissive, drop malformed, fail fast. So if you set these kind of functions, then you are avoiding loading all the in or how can I say a bad quality data. So these are the different strategies for handling all these kind of errors, and these are the most common errors you might encounter as well. So that is all for today. Thanks for joining in for this session. And before we end up, I'll just give an outro. So who are we? We are Data Valley, the fastest growing edtech company of 2025. And we have got our data centers in different places like Hyderabad, USA, United Kingdom, and UAE. So these are our headquarters. So feel free to check out our website in our sorry, feel free to check our company in the website. So you will get a good idea about how we can help you with your trainings, your placements, or let's say you're a corporate company and you want a talented people. So we help you with that as well. So we have a different kind of set. We have different kind of people who are who have multiple talents. So you can get a help from our company as well. If you're someone looking for the training or a placement, yes, we are your go-to option. So thank you for tuning in. This is Franklin signing off. I'll meet you in the next video. Thank you. Bye bye. Good luck. I wish you all a nice day.